Hi guys, welcome back to my channel. So in this video we're performing this operation in 2's complement. Okay, so for the 2's complement, our first step is of course to convert this into binary, right? If you guys already know what's 6 in binary, then it's good for you, but those of you guys who don't know, so let me go ahead and quickly do it. So you're just going to, because we want to convert it into binary, and binary is base 2, so we are going to keep dividing the number that we get until we get a 0 over here. Okay, so let's go ahead and do this. So 6 divided by 2, that's a 3, and remainder 0. There's no remainder, right? It fully divides, and then we're going to take this number 3 divided by again by 2, then we're gonna get 1, because 2 times 1, that's a 2, so there's gonna be a remainder of 1, and then we're going to take 1 again and divide it by 2 again. So every time we're taking this number, okay, and dividing by 2 until we get a 0 over here. As soon as we get a 0, we stop. Okay, so now we finally get a 0. If we do 1 divided by 2, that's like 0.5, so we get 0 remainder. So the remainder that we get is 1. Okay, so now 1 1 0, so this is your number in binary. Remember, we take this number and then put it over here, this number, put it over here. So you always look at the numbers from top to bottom. Okay, so this is your number 110. Now you want to put it into 4 bits. So again here the numbers are sign magnitude, right? Represented by sign magnitude. But here, since we're dealing with 2's complement, so for 2's complement we're always going to write the number before unsigned. Okay, like before performing the operation, we're always going to write the number unsigned. Just remember this. Okay, so here we have -6, so we are supposed to write a 1 over here as well, right? Because it's -6. But here we are not going to put that, we're going to put a 0, because we want, for 2's complement, we keep the numbers unsigned. Okay, so we have 0 1 1, and we want to put it into 4 bits. So 1 2 3, we have 3 now. Let's make it 4 bits, so we put a 0 over here. Okay, now we have 1 0 2. Okay, 2, you already know that's a 1 0 in binary, so you don't have to do this thing. So 2, so this is -6, and then we have -2. 1 0, you know it's a 2 in binary, but we want 4 bits, so again 0 0, and again we need unsigned, not signed. Okay, now once you have written these numbers unsigned into binary, the next step is to perform the 1's complement. And 1's complement is nothing, you're simply going to flip the bits. Okay, so here you have 0, so you're going to flip it by 1. So like whatever you have, you're just going to put the inverse of it. Okay, so here we have 1, we're putting 0. Here we have 1, put 0. We have 1, we put 0. Okay, simply going to flip that. Okay, now we have 0, put 1. We have 0, we put 1. We have 1, we put 0. We have 1, we have 0, we put 1. Okay, so that's it. So this is our numbers in 1's complement. Now once you have 1's complement, and to put the numbers into 2's complement, you're going to add 1 to it. Okay, so first step is always to convert into 1's complement. Okay, so after you did in the 1's complement, okay, and then you have to do in the 2's complement, and for the 2's complement you always going to add 1 to it. Okay, so you have this number, you're going to add 1 to it, and it's gonna give you 2's complement. Okay, so 1 plus 1, that's a 2 in binary, and 2 in binary, you know it's 1 0, right? So you put 0 over here, you put 1 over here, so this is 1, and then 0 and 1. So this is your answer for the 2's complement. So this is your -6. Whoa. So this is -6 in 2's complement, and then this number again in 2's complement, this is 1's complement. So 1 plus 1, that's a 2 in binary, 1 1 1. Okay, so now this is -2 in 2's complement, and now we're simply going to add these two numbers. Okay, so we have this 1010 plus 1110. Okay, so add them. 1 1, that's a 2 in binary. 0 1 1 1, that's a 2 in binary. 1 1 1, that's a 3, and 3 in binary is 1 1. So we write 1 over here, but 1 over here. But where does this 1 go? Okay, there's no number over here. The register can only store 4 bits, but here you're having a 1 extra 1 over here, so this is the case of an overflow. Okay, so this 1, you're just going to ignore this 1 that you get the overflow, so your answer is without the overflow, this number that you get over here, which is 1000, right? So I mean, you put the number in binary. Okay, so just not call it 1000. So this is your final answer for this question. Okay, so we have this next question over here. Okay, so we need to perform this into 2's complement. So again, first step is to convert this into binary. So -2, you already know that's a 1 0 in binary, right? But since we're doing 2's complement, so we take unsigned. Okay, so we're not going to put 1 over here, we're going to keep ignore the sign. And -9 in binary, that's a 1 0 0 1. Okay, if you want, you can go ahead and do this on your own, this conversion into binary, or you can put your steps in the comments below and I can check if they're correct or not. Okay, so once you have converted these into binary, the next step is to put this into 5 bits, right? So you have 2 over here, so you put 3 to make it into 5, and here you have 4, so you put 1 over here. So now these are in 5 bits. So, and of course you're taking unsigned, not the signed. Okay, so for 2's complement, you always take unsigned. So next step is to flip the bits to put it into 1's complement. So here we have 0 0 1 0, so we're going to flip it. So we have 1 1 1 and then 0 1, right? So we have like 0, we put 1, we have 0, we put 1, we have 0, we put 1, we have 1, we put 0, we have 0, we put 1. So that's what I did. So again, we're doing this one, the same thing in here. So 1 0 1 1 0. Okay, now to put these numbers into 2's complement, what do? We add 1 to these numbers. Okay, so 1 1 1 0 1 plus 1. Now we're putting into 2's complement. And make sure to know really well how to do these questions of 2's complement, because I remember in the midterm there were like yeah, I guess two questions about this operation in the 2's complement. So yeah, and one of the question I remember very well, so we had like -7 -8, something like this, and it asked like part A, we had like to perform this operation into like normal, like without 2's complement, and part B was like to do this into 2's complement. So yeah, and the rest was like the multiplication in binary, which we'll do in future videos. So yeah, okay, so we have 1 plus 1, that's a 2 in binary, so 0 1, so we have 1 1 1 1, so we have this, and then this number 1 0 1 1 0 plus 1, so we have 1 1 1 0 1, so we have this. So now our both numbers are in 2's complement. Let's go ahead and add them finally, because that's what we were initially doing, right? So we have 1 1 1 1 0 plus 1 0 1 1 0, so 0 0 1, that's a 3 in binary. 3 in binary is 1 1, right? So put 1 over here, 1 over here. 2 in binary is 1 0, so put 0 over here, 1 over here, so 1 1 1, that's a 3 in binary. Put 1 over here, 1 over here, and again this is the case of the overflow, so we're going to ignore this 1 that we get over here, and our final answer will be without the overflow, which is 1 0, which is 1 0 1 0 0.